Welcome back to the show. Today we're digging deep, literally, into the world of geotechnical engineering. When you walk past a massive skyscraper or a bustling harbor, you probably don't think about what's stopping the Earth from simply reclaiming that space. But Gregory Tschebotarioff thought about it every single day. Born in Russia and eventually landing at Princeton, he became the man who looked at the neat, tidy equations of the early 20th century and said, "This isn't how dirt actually behaves in the real world." Tschebotarioff is most famous for his obsession with scale. Back in the day, most engineers were making big decisions based on tiny soil samples in jars. Gregory knew that soil is a complex, moody material that changes its personality when you scale it up. He pioneered large-scale model testing, building massive rigs at Princeton that allowed him to see how lateral pressure, that's the horizontal push of the Earth, actually impacted structures like retaining walls and bulkheads. He was essentially the first guy to build a crash test for dirt. One of his biggest aha moments involved the flexibility of structures. Before his work, many engineers treated retaining walls like rigid blocks. Tschebotarioff proved that as a wall flexes, the soil behind it actually redistributes its weight. This phenomenon, known as soil arching, meant that we could build thinner, more efficient sheet pile walls without them snapping like toothpicks. He turned the design of waterfronts and harbors from a guessing game into a sophisticated science of soil structure interaction. If you've ever looked at a massive trench for a new subway line and wondered why the walls don't cave in, you're looking at Tschebotarioff's legacy. He was particularly interested in the lateral pressures of saturated clays, the kind of messy, wet earth that usually keeps engineers up at night. He developed methods to calculate the surcharge loads from buildings and traffic, ensuring that the pressure from a passing truck wouldn't cause a nearby basement wall to buckle. Beyond the lab, Gregory was a master communicator. His textbook, Soil Mechanics, Foundations, and Earth Structures, became the engineer's Bible for decades. He had this rare ability to take terrifyingly complex math and ground it in practical, boots-on-the-ground wisdom. He didn't just want you to solve for X. He wanted you to understand the physical reality of the 1,000 tons of pressure pushing against your steel. He was a bridge between the ivory tower of academia and the muddy trenches of the construction site. As we wrap up, it's worth remembering that the modern world is built on the foundations, literally, that Tschebotarioff laid. Every time we reclaim land from the sea or build deep into the ground, we're using the principles of lateral earth pressure that he refined in those giant test tanks at Princeton. He taught us that to truly understand the Earth, you have to be willing to get your hands dirty and think big. Thanks for listening, and we'll see you in the next episode.